All right, so for the warm-up, this first one here, 56 opens up to A, so I'm going to half him to come in and get 28. It looks like 94 opens up to B, so I'm going to half him to come in and get 47. Anytime you see a triangle, you're going to end up working that triangle. So 180 minus 28 minus 47 is 105. And remember, C is vertical, so C is going to be the same degree. Okay, this is like touching the opposite side, so I'm going to double them to come out and get 212. Okay, this, I'm going to show you distributive and box method. So you distribute the y to both terms, so y times y gets me y squared, y times negative 3 is negative 3y, 2 times y is 2y, and 2 times negative 3 is negative 6. If I combine these, we're going to get a negative 1y minus 6. Some of you also would be used to box method, so I would put a y positive 2 and a y negative 3, and we just multiply inside our box, so y times y is y squared, 2 times y is 2y, negative 3y, and negative 3 times 2 is negative 6, and then if you pull them all out, it's the exact same thing as distributing. Okay, so now we're going to be talking about tangent lines. So remember, tangent lines just touch the outside of your circle. Okay, so we have a tangent line, so that's AB. If it's a segment, segments end, so that's why it's ending in my thing. A ray has a starting point and shoots off a certain direction, so we have two options of that, as long as your arrow always goes to the right. And our point of tangency is just that point that touches the circle. Okay. So our first one that you're filling in, a line tangent to a circle, if it's touching a radius, it will always form a right angle. So if you see a tangent line connected to a radius, it will always make two right angles right here every single time. We might be testing that theory though. Okay, if two segments are tangent to a circle, so this is one tangent and this is my other tangent, from the same point on the outside of the circle, then the two segments are congruent and the angle formed by the tangent line is supplementary to the second angle. So if I form one here, okay, it's saying that these are congruent and these are congruent. Any four-sided figure means it's supplementary, okay? So if I have a tangent line connected to a radius, I just said it makes right angles. Those are tangent lines connected to right angles, okay? I know that there's 360 degrees in a four-sided figure. If I take off those two 90s, which is really 180, I have 180 left. Any four-sided figure, opposite angles are supplementary. So that's basically saying if you see another four-sided figure, its opposite angles are going to be supplementary. Okay, if the chords are equidistant from the center, so equal distant from the center, so that means these, then those chords are congruent. So if they're equal distant from that center, then both of my chords are going to be the same length. Okay, the last one, in a circle, if a diameter or radius, so in this situation we have a radius, is perpendicular to a chord, then it bisects that chord. All right, what is the measure of angle G? Well, I said if I have a tangent line connected to a radius, it makes a right angle. And then what picture do I see? I see a triangle. So I do 180 minus 90 minus 68 to get the measure of angle G to be 22 degrees. Then it says, what is the length of that radius? Okay, well, from the center of my circle to the outside, I have center to outside here, center to outside here. It's representing R, so I can represent it as R here. So if I redrew that right triangle, the short leg is R, the long leg is 12. The hypotenuse is this entire thing, R plus 9. So I've got A squared plus B squared equals, I need to make sure I square that entire hypotenuse. Okay, well, if I write out 4 squared the long way, that's 4 times 4. If I wrote out 5 cubed, it's 5 times 5 times 5. If I had 3 squared, that's 3 times 3. So it basically tells me how many times I write it out to multiply. So this squared tells me that I need to write it out twice. So r plus 9 times r plus 9. Okay, over here I've got r squared. 12 squared is 144, so I'm going to put a 144 in there. Okay, this is why we did this as a warm-up. So either box or distribute. I'm going to distribute. So r times r is r squared. R times 9 is 9r. 9 times r is 9r. 9 times 9 is 81. And then we just simplify and solve. So I know this can get me 18r. I want my r squareds to be together, so I'm not going to square root, I'm just moving them. So I'm going to subtract them. Well, r squared minus r squared, they're going to cancel. So now I've got 144 equals 18r plus 81, so I'm going to subtract 81. And divide by 18. Your r squared should cancel in this. Okay, so the radius in this represents 3.5. So the biggest part people mess up on is making sure to write this out twice and distributing it properly. Okay, our next one, I see a 4-sided figure. Opposite angles are supplementary. 180 minus 35. So angle X is 145. Okay, this one. My radius, center to outside represent the same thing, so he's X. Here's my tangent connected to my radius, so there's my right angle. So if I redraw him, because it's easier to do, short leg, long leg, this whole thing is X plus 1. So 3 squared plus X squared equals X plus 1 squared. 3 squared is 9. I write this other one out twice. And now I'm going to distribute. X times X is X squared. X times 1 is 1X. 1 times X is 1X. 1 times 1 is 1. If I subtract my X squareds, they're going to cancel. I'm going to set it up so that those should always cancel for you. So I've got 9 equals, well, 1X plus 1X is going to get me 2X. Subtract 1. Divide it by 2. X is 4. Okay, finding the perimeter, we add up all the sides. It said in one of our previous rules that tangent lines should be congruent. So if I've got 2 tangents touching my circle, that's 9 and 9. 2 tangents, 3 and 3. 2 and 2. 5 and 5. Then we just add them. 9 plus 9 plus 5 plus 5 plus 3 plus 3 plus 2 plus 2. And we get 38, and since it's perimeter, inches. All right, determine whether a tangent line is shown in the diagram. So tangent lines connected to radiuses should make right angles. So that's what we're going to test. Well, if we're trying to test to make sure it's a right triangle, we're going to do Pythagorean theorem. Center to outside is 4.5. Center to outside is 4.5. So if I redrew them, I got 4.5, 10, and 16.5. Go ahead and pause the video, do your Pythagorean theorem, and see if it equals. Okay, if I do 4.5 squared plus 10 squared, I get 120.25. This one I get 272.25. So that means it's not tangent, no right angle. All right, my first picture, it's a piece of the outside. It's an arc. Goes all the way across. Diameter. Goes from the center. Radius. Bottom right, it comes from the center. It's a central angle. So that angle would match its arc that it opens up to. This ends, so it's my chord. Tangent touches, chord ends, secant continues. So the last one I have left is bisect. Remember, bisects cut things in half and makes congruent left and right sides. Okay, then you have a bunch of words that's basically describing everything that we're going to do in this picture here. So we're just going to match things. So the first one is QGR would match with angle SGT, which would then match with angle JBK, which would then match with angle MBL. Make sure the middle letter is where the alligator mouth is occurring. Okay, then I have QR matching with TS, which will match with JK, and ML. Then we do our arcs. QR matches with ST, which matches with JK, which matches with ML. All right, so a lot of these we're going to eyeball now. So if I look at Y, what else does Y match with in my picture on the outside? It's going to match with that 120. Okay, X represents this full thing. He's going to match this, so I need to find the full thing. So if the one's 12 and this is 12, the whole thing is 24. My next one, this looks like it matches 3.2. Okay, this one, the whole thing is 10. I only want part of the thing that it matches up with. So if the whole thing is 10, it's going to match with 5. Down here, the whole thing is 20. So if I need the bottom of my right triangle, I'm going to use 10. So I'm doing Pythagorean theorem. So x squared plus 10 squared equals 14 squared. Because my x doesn't match with anything, I'm going to have to use Pythagorean theorem. So I'm going to subtract that 10 squared. And square root, go ahead and type it in your calculator. Press the double arrow. You'll get it to be 9.8. Okay, my next one I'm going to have to swing. So my radius from the center of my circle to the outside represents x, so I'm going to swing him to represent the same thing here. All the way across is 9, so this is going to be 4.5. So if you can't figure out what x actually matches by eyeballing it, you're going to have to make a right triangle. Okay, so now I've got 4.5 squared plus 1.9 squared is equal to x squared, because that's my right angle. I square root that. And I get 4.9.